The biggest reason that startups fail is that many never find product market fit. This kills more dreams of founders than anything else in the industry. Having a great idea is one thing, but building a product that people actually want to use and are willing to pay for is more challenging than it sounds. In this video, we're going to create a very simple landing page to validate a product idea. This is something that anyone can do in about half an hour, and we can count the clicks on a back end. In this case, we'll be using blockchain technology. We're going to use a Soroban smart contract to count the number of click-throughs so we can calculate the conversion rate of the landing page and figure out if anyone actually cares about the product we're offering. So what I've done here is I've built this very simple web page. This is just a single index.html web page. It's got some content and then a click button. When you click this button, it calls a function which interacts with a smart contract, updating a counter. For the smart contracts itself, I used a variation of the standard increment counter contract, which is part of the example code in Soroban examples. All I did was I modified this slightly using ChatGPT just to make it multi-user. What I wanted is a contract that any address can call, and it will keep an independent record for that address rather than having a single record for all addresses. One thing of note is that after doing this, I noticed that it missed out this line, which meant that there was actually kind of like a security vulnerability, if you want to call it that, where any user could call any address. So it's one thing to be aware of that, well, kind of these AI models are useful for doing quick things like this. You do need to check through the code, especially with smart contracts. This is just going to be used on testnet, but if you're using this in production, you need to be really careful. Let's run through this contract now just to double check it's okay. So we're importing the Soroban SDK into the stripped down Rust environment. Then we're creating this multi-user increment contract, which has this utility function for a counter key. This just creates a key for each address. And then we've got two functions, a write function and a read function. The increment function is the write function, so you pass through your address. It checks that that address is actually the caller of the transaction, and then it sets the key and it increments a counter for that address. So that address is used here with this key, and it pluses 1 every time that you call it. We're also extending the time to live for this contract every time that it's called. So if it's being used, it will keep it going basically. We're going to have this read function which takes any address you want, and it will just simply check with the storage and pass back the count to the user. This can be simulated in most environments.
Let me just take a moment to explain what simulated transactions are. So within a blockchain network, every node in the network will contain a copy of the data within that blockchain. So when we want to request read data, we're not actually updating the chain. We can ask an individual node for its copy of that data. This means we're not propagating a query across an entire decentralized network, which would be computationally expensive. We're just asking a single node to simulate the transaction or the query and return the read data based on its copy of the blockchain.
If you want to run this yourself, you can either use the contract that I've deployed, or you can fork it from this Stellar product validation, which is my GitHub repository. There's links to all of this in the description. So we'd git clone this file here, and we'd have the contract and the index.html file just here. So let's go ahead now and deploy a new version of the contract. So let's cargo build target WebAssembly. You'll need Rust and the Stellar client installed for this. There's tutorials on my blog for basic kind of deploying contracts in Soroban if you've never done it before. Once we've got that built, we'll have a WebAssembly file which we can then go ahead and deploy as a smart contract on the Stellar network. Sign in a transaction. And that's deployed. So we've got this new contract address. Let's update our index.html file. And the other thing we're going to need is a key pair. So to get this, we can go to Stellar Labs, generate a key pair, copy this public key. Don't show your private key in a YouTube video. Let's save that, and we also want to fund the account with Friendbot. This will give it some testnet tokens so that we can call transactions. That's all updated, save the file, go into the idea validator, and let's test this out. So this little question mark button at the bottom will tell us how many clicks we've got. We've got no clicks so far. We can click here, and it will say, thank you for your interest, product is currently in development, check back soon. Click OK. And then once that's gone through, we can click here and it says click once. And we're basically using a Web3 backend to store this data in a smart contract rather than a database. Welcome to the future. And now what we could do from here is take this file, index.html file, go to ChatGPT and ask it to update the text on this landing page to validate the following business idea. Type in our business idea, put the landing page in, and click update. Paste that in here, copy this bit as well, and then save that, refresh, and we've got a landing page all about chocolate teacups. And every time this button is clicked, it will store the number of clicks that we've had, and we can use this to send traffic to and then work out a conversion rate or a click-through rate for the landing page, and use that as a basis to validate our product ideas. This is a simple example of how any web developer can use Web3 technologies to store data within a Soroban smart contract and host that data on a decentralized network. If you want to learn more about building on Soroban, then there's some links in the description to Discord communities, tutorials, everything you need to get started. Thank you for watching.